Okay, so we're going to talk about logarithmic functions. So that's on page 33. I'm just going to get this ready here for myself. So what's up with logarithmic functions? Exponential and logarithmic functions are called inverse functions. So that's why we kind of bunched them together, because there's a little bit of a connection. There are patterns that we can draw from one to and then transfer them over to the other. Basically, the x and y variables switch. Okay? The domain of one becomes the range of the other. Why I don't like this, and I'm not going to highlight that, okay, is we will never switch variables, guys. The first column is always going to be x. The second column is always going to be y. We're not going to switch. I will tell you what this refers to in a little bit. Okay, I have a sticky note for that. The expression log of x, is the common logarithm, and it's expressed as base of 10. Okay? So we have log, and then we have something we call ln x, which is the natural log. And the only difference between these two is that one is a base of 10 and the other one is base of e. Do you remember e? Euler's number, which is 2.718. It just keeps going forever. Okay? Guys, they behave exactly the same. They have the same properties. They just have a different base. It doesn't really make a big this one I don't need you to remember. I don't need you to memorize this part. But they are different, slightly different, but they behave the same way. Okay? They never cross the y-axis. They never cross the y-axis. This is due to horizontal asymptote. Remember that one? Due to the horizontal. Both log and natural log do have the same properties, but when graphed are slightly different. Here's the logarithmic in general form. Okay? It will always look like this. You don't have to worry about a different format. Okay, so this is all worth boxing and highlighting the entire box. I will give you a little bit of a study sheet entry as we approach the end of this unit to kind of summarize this as best as I can for you. Okay? So both of them have, I'm going to have two different colors. I'm going to have pink and orange here so to really make this stick out. So whether it is log or natural log, okay, the A here, let's give that pink. The first number, okay, what's interesting about this, whatever that number is going to be, we call it A, is going to be a point 1A on the graph. Emphasis on the 1A. So you're basically saying, if this is 10, then you're guaranteed that one point will be 110. If this is negative 500, then you know that one of the points on this graph is going to be 1 negative, what did I say, 500? Yeah, 500. Okay? Always include, this is, I will cross this out because it's not true when it's a word problem. So I'm going to ask you to please, you got to use always. You have to use that very carefully. I noticed in almost anything, right? Don't say always unless it's always, right? So I'll just say that is true. 1A is always there. Next, this second one here, so A, right? I'm going to give this also a pink here. The next part is B. Okay, that value there. B determines, right, whether the graph is increasing or decreasing. So basically, if you look at B, and remember, B is all of this, okay? The sign and all. It's positive here, but it will not always be positive. If B is greater than 0, so positive, you're going to have an increasing function from left to right, okay? If B is negative, if you notice that the orange part, right, this whole thing here is negative, you're going to have a decreasing function from left to right. Okay? So you can have arrowheads here. And what do both of these have? They do have x-intercepts. That was a big no-no. That was a big no-no for our exponentials, right? They never cross the x-axis. This one does. And here's your asymptote. This one has an asymptote here. At some point, we're going to make sure we have that clear on our study sheet. What is the asymptote for exponentials? It's y equals to 0. The asymptote for this is x equal to 0. That's the asymptote. What happens? Come on. Asymptote. Okay, same here. X is equal to 0 is also the asymptote there. So increasing, decreasing. It's basically the sign of B. Okay. Next. Characteristics of logarithmic functions continued. For both increasing and decreasing functions, the following is true. The end behavior is always quadrant 1 to quadrant 4. Regardless if it's doing this, this is 1, this is 4, because remember the axis is here, okay? Or if it's increasing, guess what? We're still going from 1 to 4. It doesn't matter which way you look at it. If it's increasing or decreasing, it never crosses here. It just never, like 2 and 3, those quadrants are not even an option. It just never crosses there. Okay. X-intercepts, logarithmic functions, cross the x-axis and therefore have one x-intercept, but they have no y-intercepts. I made a mistake there. Can you change this to a y? No y-intercepts. Let's talk about the domain and range. What would be the domain in general for both of these? Does it ever really get to 0? No, but it gets darn close to 0. So domain is going to be 0 to infinity. Like, right, the other end, it never stops on the right side. See how 0 has a round bracket? That's important. Or you can say that x is greater than 0. What's the difference? It doesn't have the equal sign, okay? No equal sign, it's just greater than. For range, it's negative infinity to positive infinity in general, okay? Or y is all real numbers, sorry. There's no greater than. It's everything. If there's no word problem attached to this thing, we're saying, you know what? As far as down as you can go or up as you can go, it's all real numbers are part of it. Okay? So that's your logarithmic functions. And here's the sticky note part. Why did I talk about the flipping? Just make sure you copy that down. drum roll. Okay, here we go. Why is it the flipping? I want you to think of things being flipped. So imagine our exponential. We used to have an exponential function. This one increases, right? What if the y becomes the x and the x becomes the y? Like this is what's happening. Watch. You ready? If you were to flip this sideways, right, you now have your asymptote here. It will never cross it, but you do have an x-intercept. Okay, so that's this logarithmic function here. So that's how they are related in a sense. Okay, that if you were to take this exponential and you wanted to turn it into a logarithmic, you'd have to flip it like that. Okay, and so all logarithmic functions have an asymptote going up and down called x is equal to 0. All exponential functions have a horizontal asymptote called y is equal to 0, which I will summarize for you later on. Okay? Continue. We'll do a little bit of sketching here. Sketch the following. Okay? So we have this equation given. This is an exponential function. A is equal to 2, B is equal to 10. That means that 0, 2 is part of this. And since B is greater than 1, this is increasing. So we narrow it down. So at first, when you just look at it, I hope you understand this is exponential. What are our options for exponential, folks? It would be either this, or it would be this. Okay, like those are my options for exponential. But then I narrow it down even further because b is equal to 1. It's increasing, so it's going to be that one right there. Okay, so let's make a sketch here. This is just a sketch, so I'm gonna include the asymptote. This is y is equal to 0. This is 1, 2, 3, 4, 5. I know it goes through 0, 2, and I know it's increasing, so it's gonna go like this. This is just to envision what's happening, right? What to expect. I'll do 2 and then you will do 2. Okay? Over here, I mean, you can't miss a logarithmic, guys. It'll either say log or it will say ln. Like you can't miss it. There's no, like it's going to be plain and simple. Okay, so this is logarithmic. What are my options for logarithmic? It can either be coming down like this, or it could be going up like that. It could increase from left to right. 2, a is equal to 2. B is equal to what? What's b equal to? What's right in front of log here? 1. Right? It's not 0, it's 1. Otherwise log wouldn't be there. Okay. So it's positive. That's all we care about. We don't care about the actual value. B is positive. Okay. So that means that we're looking at something like this. And what does A tell me? It actually gives me a point. It's 1, 2. Not 0, 2. That's exponential. It's 1, 2. So we can sketch this now. So I'll go 1, 2, 3, 4, 5. And I'll go 1, 2 here. So one thing I know is that 1, 2 is going to be on this graph no matter what. Like that's something that you can kind of anchor yourself on. And so if you want, you can say like it goes to here, and from there it goes this way. Okay, so this is the sketch that we're after. If you want to label that point 1, 2, that's what I would expect you to do in that case. Hold on, let's do our asymptote. Okay, this is the line x equals to 0. Okay, never crosses it. Could I ask you to do the same kind of thing with these two questions underneath? Don't just sketch right away, kind of narrow it down. Like, what is it telling me? What do I know? And then sketch it, okay? As best as you can. I don't need a detailed graph, I just need a sketch. And that gives me a little break to get my water, okay? So I'm going to leave that there if you're still copying. Try the same activity down there, okay? We're good? This one looks like a. I hope you understand it's exponential. Why? The t gives it away, the exponent. I told you about the ugly ones, right? What are you talking about? They're all ugly, Mr. Dirksen. We'll do that later. Right now, let's just focus on one thing. Sometimes the exponent has like a fraction. It's like t to the, like over 3. Don't worry about it. Just type it in. It's still exponential. So we know that a is equal to 4. So 0, 4 is a point. B is 0.76. Because it's between 0 and 1, it's decreasing. Okay, we know it's decreasing. This thing is going down, right? So the graph would look like this. We know it never crosses the x-axis, so I'm not going to bother. It starts at 4. 1, 2, 3, 4, 5. I'm going to make a 5 mark there. And it starts at 4, and I'm going down from left to right. So it goes like this. But it never touches, okay? And because this is not a word problem, I want you to also do this, okay? So it's kind of like a curve that does something like this. Okay, that's what we're expecting there. This one is a logarithmic. A is equal to 5, therefore 1, 5 is on the graph. B is -2. Negative means decreasing. Okay, it's going down from left to right. In this case, it's going to look like this. 1, 5. So I'm going to go 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, this is 5 up here. So 1, 5 is on this graph for sure. And it's decreasing from left to right. So guys, no matter what you do, if you travel from left to right, it has to go down. So if you want to start here and then just go and do this, it's going to cross at some point and then go like that up there. So it's decreasing from left to right. Okay? That's what is happening there. So we're going to now start our word problem segment.